Welcome everyone who has made it to our talk on connecting the dots, which is a brief 15-minute talk on the role of open standards in next-gen telecommunications. So, what you'll expect to see in this presentation is types of open standards, how open standards forge the internet, so a tiny history lesson. Hopefully I make it funny. And where open standards are enabling innovation in networks today. So, who am I? Well, 15 years software experience, specialist in high throughput network code. I mean, you can read, but yeah, I'm just an engineer, basically. And yeah, I have a startup. We're going to be tight on time because I've got quite a lot of slides, so I'm just going to skip over the rest. So, what are open standards? Well, generally, they're separated into three categories: data exchange, sharing vocabulary, and guidance. Data exchange is things like file formats, APIs, schemas, etc. Well, everyone knows a dictionary, but there's also things like codes and identifiers for sharing vocabulary. In the case of fiber optic operators, they use a lot of GIS data, and GIS data is commonly has its coordinate system as WGS 84. And of course, a lot of these codes and things we see come from ITU-T for fiber optic classification as well. So you have things like G657, which is a type of 9-nanometer fiber optic. Yeah. Guidance as well, so we have best common practices, we have vulnerability publications, and the code of conduct that we all agree to when we come to conferences like this. So, who maintains them? Well, I already mentioned ITU-T. They do fiber classifications, things like CWDM and DWDM channels. They're responsible for SS7, which is how your phones know how to make a phone call. And then we have IETF, who, you know, as you'll know, do RFCs. RFCs are responsible for IP, DNS, MPLS. I mean, again, you can read. Sorry, my slides are going to be very wordy because I'm not a very graphically minded person. And then we have companies and individuals. So here we have things like the Open Document Format, Swagger/Open API, and two of the ones that I'm going to be talking about in a bit, which is the Open Fiber Data Standard and the Open Standard for OTDR data. So, brief history of open standards, why they matter in the first place. Well, it all starts with IP. In 1980, University of SoCal released DoD Standard Internet Protocol for DARPA as RFC, 760. Well, that doesn't sound terribly early, does it? 760, that's pretty late IP, well, RFC number. So maybe it starts with IMP. In 1969, UCLA released RFC1, host software, which formalized the communication over the first internetwork using TTY. But what's TTY? Well, TTY originates in 1870 with Jean-Maurice Émile Baudot, who invented Baudot code, which then got classified as ITA, or the International Telegraphy Alphabet. That's it. For transmitting telegraphs from machine to machine. It's one of the first machine-to-machine communications standards ever devised. So, sometime after that, in 1932, ITA-2 was released by CSIT, the predecessor to the organization we now call ITU-T. And then, because that didn't support Cyrillic characters, Russia decided to release MTK-2. And because Russia did it, the USA did it. They released their version of the standard called USTTY, or US Teletype. And then, 1963, based on that, we got ASCII. So, that brings us back to IMP again. 1969, UCLA released RFC1, host software, as we mentioned earlier, which was the first formal document that described the internetwork communication protocol, which used ASCII teletype between IMPs, or interface message processors, which these days we would know as routers. This was arguably the first packet switching protocol in the world, enabling communication between the first 4 sites of ARPANET. And what does this look like without standards, right? We need a good example for how the world would look and how the internet might look if we didn't have standards. Well, fortunately, we have power grids. Power grids are a very good example of what happens when you don't have international standards. Let's look at Europe. We have 5 grids, 3 consumer voltages, and 6 independent plug types, some of which are compatible with each other. The USA, well, North America, we've got 6 grids, 3 inside the USA alone, 2 consumer voltages, and 5 plug types. And Asia, well, there's at least 19 grids that I'm aware of. There's at least 6 consumer voltages, and as far as I counted, 11 independent plug types, some of which are kind of compatible. You can kind of group them into 5 groups, basically. So that brings us on to open standards and innovation. So how do open standards actually drive innovation? Well, let me introduce you to SR 4731, otherwise known as the bane of my existence. This is the definition, well, rather, this is an excerpt of the license for the definition of the standard OTDR record. The standard OTDR record describes how fiber optic test data is stored and shared between parties. So when you test a fiber, you send a really bright pulse of light down the fiber, and then you look at 3 to 300 nanosecond samples, the Rayleigh scattering that's coming back off the imperfections down the fiber. Now, this license, I've highlighted a bit there, says that you can't create any derivative works from the document. And I checked with their lawyers, does this count for software libraries that implement the standard? And they said yes. So originally, this was a standard released by a company called Belcore, and it had a very reasonable license that allowed you to actually implement it. Belcore got bought by Telcordia, who, again, continued to upgrade the standard and release it under a reasonable license. But then at some point, it got bought by Ericsson. And Ericsson's lawyers, in their massive brain kind of capabilities, decided, hey, we're not using it, let's make it so that no one else can use it either. And so the license now says you're not allowed to create any derivative works. Now, technically, they say for sale. So I asked them, can we make an open source version if we get the standard? Again, they said no. So what do you do in this case? Well, I'm based in the UK. Fortunately, it was in Europe, and we have a common set of laws around reverse engineering. So we released the Open Standard OTDR data, or Open SOD. In the UK, I don't know how many people know UK slang, but a SOD is someone who you don't particularly like. It's actually slang for, well, it comes from Old English for a clump of dirt. So yeah, Open SOD. It's an open source version of the standard. Reverse engineered, it took me about 3 weeks. I would have far rather had spent $750 to purchase a standard that I could use and could implement, but hey, that's where we're at. And what's this allowing us to do? Well, first off, we got a lot of feedback from other implementers and other engineers that have also either reverse engineered the standard or want to implement software on top of it. And so we started working on the first request for comments for this standard. And this actually implements something that people have wanted for a long time in the standard, which is the ability to carry multiple wavelengths of test. The reason you want multiple wavelengths is because it tells you if there's a bend in the fiber. Without multiple wavelengths of light, you can't see a bend. Thank you. So, why do we care about this? Why do people actually care about this standard in the first place? Well, this is how we generally receive test data. It's a PDF, it's got a graph on there, and on that graph you can see some events. Those pulses could be breaks in the fiber, they could be couplings, we don't know. And the best thing that you can do about it is kind of look at that, estimate how far along the fiber it is, and then go and try and repair it. So, using our implementation of the standard, I wrote a piece of software that actually allows you to zoom in on the data set. And then, using a bit more stuff and some GIS data, I made it so that you can actually identify where along the fiber it is without needing to try and pinpoint on the graph and then convert that into a distance along the GIS path. With a bit of a confidence variable, we can see it there around the particular bend. Now, I mentioned we'd come back to the Open Fiber Data Standard, so what's that, and why does that matter? Well, the Open Fiber Data Standard, as you can see from the spools of cables that I hope Mozilla will forgive me for stealing that picture from, was made by the World Bank and Mozilla and a couple of other contributors for documenting fiber optic data, where it is in the world, how it's deployed, how many fibers there are, and who it belongs to. So this includes geospatial data, technical data, and administrative data, such as I said, who owns it. But why does that matter? Why do you care, right? Well, let's say my network exists in 2 cities, and I've got a customer that wants a connection between those 2 cities. I can get across the cities on my network, but between those cities, I don't own any fiber yet. Now, I can go and get licenses and dig a trench and put new fiber in, but that's going to take weeks, and it's not going to be particularly pretty, and it's going to be very expensive for one client. I'm not going to make the money on that unless I make 10 clients use that connection. So that's not very sensible. Now, what I could do, if I knew where your network was, is use your network in the middle. Your nice little sparkly network. That's going to save me a lot of time and money, right? And that's exactly what World Bank wanted. They wanted the fiber deployments that they were sponsoring in Africa to not overbuild. So essentially, we're not trying to compete on where the paths go, we're trying to compete on products that we provide over those fiber paths. So that's why standards really matter, and why open standards kind of are key to the future of telcos. Hopefully, I managed to get that in on time. I think I saw the 5-minute a while ago, so we have time for questions. Sorry if it was a bit rushed and a bit heavy on kind of words. Any questions? No? Great. Well,
how much adoption are you getting of your OpenSOD standard?
Of OpenSOD. So at the moment, there's 2 implementations written by me, one in C# and one in Python. We've got quite a few people using our implementations that run on top of it. So OpenOTDR, for example, has received, since we released the alpha version with 0 fanfare, with 1 LinkedIn post, we're getting 191 downloads a month, which doesn't sound like a lot, but 191 downloads a month is a significant portion of the fiber optic technicians in the world by now. So it doesn't sound like a lot, but it's actually quite a large percentage of the interested population. So yeah, and there's other things that I'm building on top for very large ISPs for identifying and finding issues in their networks automatically. So that's generally speaking what my company is doing. Yeah. No? Great.